Okay, I want to do a really quick example of how to do the work for this week. So I'm going to do the first one with you. So you're going to look at the reaction that says sodium sulfide reacts with copper 2 sulfate. And I'm just going to look at each number, so 1 through 4. Number 1, it tells you it's a double replacement reaction. So you need to identify the cations and anions in both reactants, all right? And then we're going to write out their charges. Little reminder, right? Cations are the positive charge, anions are the negative charge. Metals are cations. Okay, they're always going to have a positive charge. And then nonmetals will have the negative charge. Okay, so then let's look at the reactants, right? We have 2 reactants, sodium sulfide and copper sulfate. Which one is the cation in sodium sulfide? Which one is the metal? Sodium. So sodium is the cation. So I'm just going to write sodium over here. And then remember that to figure out the charge, we look at the column it's in. So sodium is in that first column, so it's going to have a +1 charge. So if sodium is the metal and it's positive, then sulfur must be the nonmetal, and it's going to be negative. So sulfur, right, for nonmetals, you want to count backwards from the noble gases. So how far away is it from the noble gas? It is 2 away from the noble gas. So it's going to have a 2 minus charge, right? It's right under oxygen. It's going to have the same charge as oxygen, -2. So let's look at the second reactant, copper sulfate. Which one of those 2 are which one is the metal? Right, we have copper and sulfate. When you think of copper, you know it's a metal. You've seen it. So copper is the metal. And if you look, right, on your paper, it says copper 2 sulfate. Remember, the Roman numeral tells you the charge of the metal. So it's copper 2, and it's plus because it's a metal, so it's a cation. Copper 2 plus. Okay? And then that leaves sulfate. It's a polyatomic ion. We've made a list before, so you want to review that list. It's okay if you don't have it memorized. But I'm going to go ahead and remind you that it's 2 minus. And also, you can tell by looking at copper sulfate that sulfate should be 2 minus, because if we know that copper is 2 plus, then they balance each other out. They're going to have a net charge of 0, right? 2 plus and 2 minus is going to equal 0 together, right? And that's why sodium here in this reactant, there's 2 sodiums because each sodium is a +1 charge. So it's really +1 + 1 minus 2. So +2 minus 2 is 0. So you always want to have a net charge of 0. Okay, number 2. So this is just reminding you of how double replacement reactions work. Like replaces like in a double replacement reaction, which means that metals will replace metals. Okay? So the directions say, pair the cation of the first reactant with the anion of the second reactant. So remember, we have 2 reactants. We have sodium sulfide, copper sulfate. So let's look at the first reactant, sodium sulfide. So it says pair the cation of the first reactant. The cation, we already said, was sodium. Pair the cation of the first reactant. I'm going to write the second reactant with the anion of the second reactant. So let me write out cation of the first reactant with the anion of the second reactant. Remember, so we have to do the crisscross method. If you remember, right, this has a +1 charge, this has a 2 minus charge. Crisscross tells me I'm just going to drop this down here, and I'm going to drop this down here, right, crisscross. So then I end up with, oops, I'll write that back. I end up with sodium to sulfate. Okay, and so that's that product. And then the second product is going to be, you're going to combine the cation of the second reactant, which is copper. So let me write that, with the anion of the first reactant, which is sulfur. Okay, so copper sulfide. And copper is 2 plus, sulfur is 2 minus. When I do crisscross, they end up with 2 and 2, which balance out, right? Because it's really 1 to 1. So I'm just going to write copper sulfide. Copper sulfide. Okay, so that's the products. That's what number 2 is. Number 3 is balance the reaction. So remember, balancing is simply saying I should have the same number of atoms of sodium on the reactants as I do in the products. And that should be true for all of the elements. So that's what we're going to do. Let's look at sodium first. So sodium has, I'm going to write my little list. Sodium has 2 on the reactant side and 2 on the product side. Perfect. Sulfur has 1 on the reactant side and sulfur has 1 on the product side. Also fine. Copper has just 1 on the reactants. Copper has 1 in the products. And then finally, we're going to keep polyatomic ions together always. So sulfate, there's 1. Sulfate. In the products, there's 1. So everything is balanced. So if I have to write the balanced equation, it's just going to be the same equation. I'm just writing it a little lower. Right? So I'm rewriting the same thing just to make the point that I checked and it's balanced. So I'm allowed to just rewrite it. Okay, that's number 3. And then number 4 for each of these problems is you're going to watch the actual reaction take place. Right? So you're going to go to YouTube and I'm going to try, I don't know if you'll be able to hear the sound, but, oh, you okay? But I'll play it for you. Right, so this is the sodium sulfide with copper sulfate.
In the double displacement reaction of copper sulfate and sodium sulfide, we start out with a light blue solution of copper sulfate. We will add a colorless solution of sodium sulfide. When the sodium sulfide is added to the copper sulfate, we get a rapid formation of a brown-black solid. The brown-black solid is copper sulfide.
Right, so if you saw, I'll go back because at least you can see this. Right, the blue is the copper sulfate. And when you add the sodium sulfide,
when the sodium sulfide is added to the copper sulfate, we get a rapid formation of a brown-black solid. The brown-black solid is copper sulfide.
Okay, so I'm going to go back. So the question 4 is simply, I want you to look at the reaction and I want you to tell me what you notice, right? So I would say, right, copper sulfate is blue liquid, and then I would say, sodium sulfide is a clear liquid, right? So these are just, I want you to describe what you're seeing. What did we notice? When they mixed together, there was a color change. So I would say there was a color change. Obviously, please write incomplete sentences. I have limited room. But there was a color change during the reaction. Right? It went from blue to brown. Okay. So it went from blue to brown, and also, if you notice, it's hard to see, but you have to listen to the video. There's a solid formed. So there was solid formation, which is also called a precipitant. So the question in number 4, it says, how can you know that a chemical reaction has taken place? So if you had to tell someone or prove to someone, right, convince someone, no, a reaction definitely took place, what would you say? So I would say, I mean, we already said it, but there was a color change, right? Color change is usually an indication of a reaction happening. And then solid formation. So think about it like this. If something appeared that wasn't there before, that means something must have happened. So the formation of a precipitant is evidence that a reaction has happened. Okay, so as you do the other problems, that's how I want you to answer these questions. It's simply writing down what you see for number 4 when you watch the YouTube videos. And then if you have any questions, feel free to reach out to me. I hope this helps you.